Welcome to Chakwa International. I am Nilamatu speaking. This is related to video number 401, Introduction to Communication System. This subject is a part of the electrical engineering syllabus for GATE on engineering service examination, also civil service examination. Due to limited viewership, the financial condition of Chakwa International is beggars description. So we are forced to divert the uploading a video in the related segment of the GATE syllabus to increase the viewership. And this is a part of the same direction. We are uploading this for the GATE and ESE allowing for JEE main physics. Similarly, upload for the JEE main mathematics also. The detailed program will come tonight midnight. Communication is the process of establishing a link between two points for information exchange. Communication is the process of establishing a link between 2 points for information exchange. Block diagram: information short, input transmitter, channel, receiver, output transition, noisy. The propagation of electrical signal through communication channel takes place in the form of electromagnetic waves. Wire communication electromagnetic signal propagate in the form of voltage and current waveforms. Wireless communication it propagate from the radio waves. In optical fiber communication propagate light wave. In analog communication it propagated through it propagate electrical voltage and magnetic field. Propagate to air and space is called the electromagnetic wave. Second, the input transducer function convert signal to electrical signal. Transmitter convert analog digital signal to a form suitable for transfer of a particular communication channel. Communication channel provide a means for transmission of electromagnetic signal between transmitter and receiver. Twisted pair, telephone cable, coaxial cable, optical fiber. Unwanted electrical noisy signal is unwanted electrical signal is called a noisy signal. A receiver accepts the signal from the communication channel. Output transducer convert the signal from receiver to desired analog and digital form of information. Desired parameters: bandwidth signal, communication channel, data rate, amount of noisy, and level of acceptable error rate. Information signal may be analog or digital. Transmission may be analog or digital. Communication channel may be wired or wireless. Communication may be baseband or broadband. Direction transfer may be simplex or duplex. Data may be sent for 1 bit at a time or more bit at a time. Analog signal is a continuous varying signal. Digital signal is a sequence of voltage pulse. This is one model of analog communication, model of digital communication. Analog information data is encoded to produce digital bit stream using codec. Codec means coder and decoder. Here the baseband information signal generated from source. Information signal generated from is a source is called baseband. Broadband, the low frequency baseband signal is impressed upon the high frequency analog carrier signal. Modulation, when information signal ride over the carrier, it is called modulation. Region suitable to a long distance transmission to reduce the information loss. Demodulation, process of separating the message signal from modulated carrier signal. These are the sample. What is the message? What is the carrier? Then this is the complete wave. Message signal to be sent to destination. Carrier signal generated by the transmitter, and this is A, B, and C the total signal. Here why modulation we need: reduces antenna height, avoid mixing signals, increase the range of communication, allow multiplexing, allow adjustment bandwidth, improve the quality of reception. This is the formula is there. This is self-explanatory. So we should know what is the modulus index EM by EC. Modulus index more than one, that is called over modulation. A signal we lost. This is the, we have the calculate, this is the one calculation, there no need explanation. We should know what is the bandwidth, it is a 2 FM, and what is the, this is the formula of the modulation index, EA max by E mean divided by E max plus E mean. Here we have simple calculation, what is sideband frequency, what is the power in the sideband, like this. This is the, what is the propagation of EM wave. Ground wave propagation from transmitter to receiver by gliding over the surface earth is called a ground wave. Surface waves hit the earth's surface are reflected towards the receiver. Direct wave shortest propagation distance between transmitter and the receiver. Sky wave, the medium and high frequency are communicated using sky wave propagation. Reflection electromagnetic waves from ionized regions or atmosphere used for transmission waves of longer distance. Ionosphere reflects back the EM waves. It is called a short wave propagation. Point-to-point communication is possible. Here is space wave propagation. Troposphere used for the space wave propagation. Frequency around 30 MHz to 300 MHz. Space wave reached the receiving antenna directly from the transmitter or after reflection on the troposphere. Satellite communication, there is a uplink, the downlink is there. Communication satellites are used to send and receive the radio signal for television, phone, concave reflectors are used to send and receive the signal. Electromagnetic waves are used as a carrier. And here one problem is to find the transmitting range of antenna height 160 meter. The range is 2 RST to the power 1 by 2. Here ST they given that height of the antenna 160 meter, radius of earth is 6370 kilometer, so range is 45.14 kilometer. This is the formula 2 into 0.16 into 6070 root over 45.74. There is a type of modulation, and this is the analog modulation and pulse modulation. Analog modulation is divided into amplitude modulation and angle modulation. The angle modulation is divided frequency modulation, phone modulation, and the pulse modulation. The digital and analog, and digital also is called the pulse code modulation. Analog pulse for PM, PDM, and PPM. Here the range, so what is the service is available for different frequencies. This is collected from the NCRT. There is a different layer of atmosphere for the communication, that also we collected from the NCRT. Here one numerical part is there. Completely numerical, because we are going to operate for the first phase. JEE main January examination only virtual numerical. For the April examination we'll put numerical for related theory. Here the fastest carrier signal is given, amplitude modulated by modulated signal is given. Here Vm is equal to 2, Vc is equal to 5. That was what is the modulation index? Vm by Vc, that is 44, 0.4%, 40%. Then display of amplitude of an oscilloscope is showing Vmax is 180, V mean is 45. Peak to all are peak to peak. Find the modulation. Modulation Vmax minus V mean divided by Vmax plus V mean, that is 0.6, that is 60%. A carrier signal 8 volt peak is amplitude modulated by frequency with peak amplitude of 2 volt and 4 volt. So you have to calculate what is M1 2 by 8, M2 4 by 8, then result of wave is equal to M1 square plus M2 square root over, that is 0.559. Here the modulating signal 5 sine 2 pi 10 to 3t by carrier signal of 10 into sine 2 pi 10 to 4t. Calculate the frequency. Here the actual signal is Vm 5 sine 2 pi ft. In first case Fm is 10 to 3. In second case Fc is equal to 10 to 4. So what is the Am is equal to? Am is equal to Fm by Fc, that is 5 by 10, 0.5 into 50%. Upper sideband 10 kilohertz plus 1 kilohertz 11 kilohertz. Lower sideband 10 kilohertz minus 1 kilohertz 9 kilohertz. Bandwidth 2 Fm 2 kilohertz. Amplitude upper sideband MVC by 2. Here VC is equal to 10. Am is equal to 0.5, at 2.5 volt. And lower also same 2.5 volt. The next question, radio wave. This is the most important. Radio wave incident on ionosphere at an angle 30 degree. Critical frequency is 1.6 megahertz. Find the maximum usable frequency. Maximum usual frequency is equal to Fc into sec 30, because 30 is the angle of incident. So 1.6 sec 30 2 by root 3 is equal to 1.5 megahertz. Find the skip distance. Skip distance is nothing, 2h root over f maximum usual frequency divided by critical frequency square minus 1. So it is coming 1.136 kilometer. This is coming 136 kilometer. Critical frequency for a layer determines the highest frequency that will return down to earth by the layer after having been by the transmitter straight up into the sky. Rate of ionization density when changed conveniently through the layer, the wave will bend downwards. The maximum frequency that gets bent and reaches the receiver station with the minimum attenuation is called the critical frequency. For a frequency above 30 MHz, the sky of propagation exists. The signal is multipath, and which is reflected from the ionosphere can be called a hop or skip. Fading, the decrease in quality of the signal can be termed as a fading. Skip distance, the measured distance on the surface of the earth from the transmitter to the receiver where the signal is reflected from the ionosphere can reach the receiver with minimum hops or skips is called the skip distance. Maximum usual frequency is the highest frequency delivered by the transmitter regardless of the power of transmitter. The highest frequency which is reflected is equal to critical frequency divided by cos theta. What is called critical frequency into sec theta. The optimum working frequency, the frequency which is being used mostly for a particular transmission which has been predicted to be used over a particular period of time over a path is known as a optimal working frequency. With this, the presentation is complete. Like, subscribe, put the bell icon. Thank you.